Okay, hello everybody. How's everybody doing this fine afternoon? I hope everybody is doing well. Good to see everybody today. I hope everybody is ready, raring to go here for another Math 102 session. Hopefully everybody's doing absolutely fantastic. Good to see everybody today. Hello, hello, hello. We'll get started here in just a few minutes. We'll have a few more people start coming on in, and then we'll get going. Just as easy as that, ladies and gentlemen. So, we will. Hey, good evening to you, Hisa. How are you? How are we doing this fine evening? Hopefully you're doing well. Hopefully you had a nice weekend. So, we're almost getting there. We're getting close to being done, Hisa, if you can believe that. I can't believe it either. So, we have like a very good, Hisa. Hey, Pistache, hello, good evening to you. How are we doing? How are we doing today, Pistache? We have, we don't have much to do today, honestly, but, we will do what we have to do. Doing okay? Well, I promise you today will not be super long, okay? Today will be a little shorter than normal. More than likely? Question mark? Maybe? We'll see. Honestly, it won't take us too much time to do this next part, so. But we can all wrap it up in a couple of examples. It should be pretty simple. We got only like today's section, and then we got next class, and then we got Tuesday, and that's it. That's all the new material that we have to cover. Now I think, if I recall right, I gotta check that actually. I gotta check the academic calendar. I forgot to do that actually. Because I forgot what days off that we actually have, right? So. We have like. Don't we have next Wednesday and Thursday off? Or we're not meeting next Thursday, I thought, right? I'm like blanking now. I'm like, one of these days is right. Alright, let me check. Yeah, next Wednesday and next Thursday, alright. Next Wednesday and Thursday, we're off. Alright, that's fine. Yeah, so we won't be meeting next Thursday. We will still be meeting next Tuesday, though. So, we will still be meeting next Tuesday. Yeah, next Thursday's off for Thanksgiving, and then all of you can go shopping Black Friday. Do whatever it is that you do. It's pretty bad. Oh, get that easy peasy lemon squeezy. Let me bring that up. Need to bring up this guy. It's out here. It's not important. There we go. It should set us up there. Alright, we'll get started here in just a few more minutes. You guys can sit and chill out, hang out for a little bit. We'll go get started here about 5 past. I think 5, 6 past will be alright. And we'll get going here. We'll wait for a few more people to start trickling in. You can see some people already start to trickle in. This is good. Alrighty. I wonder if I should do that. That's a good question. Let me think about that. Okay. Hmm.
There's a distance between us. It's getting hard to reach out. Haven't seen you in seasons. But all I hear is your voice.
Okay. That's a possibility. Alright. I'll have to think about that. Alright. Alright. I wonder if I should... you know? That would be interesting, wouldn't it?
For quite some time now, just to see you again. And I've been counting days to get away, to see you again, see you
Alright.
again.
That's true.
Been fighting ways to get
That's true.
away, to see you again.
That's true. Yeah, that's something to consider. Alright. Alright, ladies and gentlemen, we're going to go ahead and get started here. Let's go ahead and do some intros. Alright, hopefully everybody is here, raring to go, because we are about to set off. Let's do some intros. Let's get going. Alright, let's do it. Okay, let's get started with today. Welcome back to Tuesday. Hope a nice weekend. Alright, so for today, ladies and gentlemen, we are going to continue to move forward here in Chapter 4. Alright, so last time we talked about the correlation coefficient R, we talked about scatter plots, we talked about a lot of very important things here within this chapter that certainly needed to be addressed. A lot of things just kind of had to tie together. Now, we figured out a way about how to solve for R here. Hey, what's up, Kill Machine? How we doing, my friend? Go big or go home, that's right, man. So basically, if we're going to look at section 4.2, it's going to be an extension off of what we did here last time. It's an extension off of what we did here last time. We found what R is, the correlation coefficient. We also determined whether or not, depending on the sample size, if the correlation coefficient R that we found here actually would indicate a linear relationship between both X and Y, or whatever X and Y are in that particular context. Now, today, we're going to figure out exactly if, say, there is a linear relationship between X and Y, exactly how good of a predictor it would be given the particular circumstance. You know, we've figured out how strong a relationship is, but, you know, what if we actually put actual numbers to say what that model could predict in that particular given frame. All right, so how do we do that? How do we get some modeling in essentially here today? Well, let's go to the big board here, ladies and gentlemen, and let's find out. All right. So let's take a good look here at section 4.3. We are going to talk about the line of best fit. All right, so let's go to the handout here. All right, so we are going to talk about the line of best fit here. As we talked about here, we talked about linear relationship. Now we can actually say, all right, well, what model best reflects the data set in question? Well, we need the line of best fit here, i.e. it is also called the regression line, just a very fancy way of saying line of best fit. I like line of best fit because it's a lot more basic and it's a lot easier to understand. You're like, okay, it best fits the data, very simple to remember. In any case, all lines of best fits are pretty simple to, at least you know. All lines in mathematics are y equals mx plus b of some variety. Alright, so now the way you can solve that here is, of course, you can find the slope here, which is m. So remember that m here is the slope, and b here is the y-intercept, as it says down here. Now, m here is equal to using the r that we found here last time, the correlation coefficient. Alright, and then we multiply that by the standard deviation for the y's divided by the standard deviation of the x's, and then you can go ahead and find out what the y-intercept is by using the slope from what you found from before. So you do this in order. You find the slope, and then you find the y-intercept here, and then you put it together in a line. Now, of course, doing that by hand is taxing, okay? So Obviously, we're not going to really do it by hand, but what we want to look at here is, of course, how we can go ahead and use this line of best fit in given situations to see exactly how good the model is going to be. Now, as I stated here before, again, slope and y-intercept do mean the same thing as they do in regular math problems, i.e., m being the slope here being the rate of change. Okay, we'll describe a little bit more here and when we do an example. And we'll have b here, the y-intercept. This is if x is equal to 0 given that particular context. Okay. Now that's all well and good. Yeah, we'll talk about that. That's all well and good, but let's take a look at an example here. Let's look at the book. See how we can approach that here. All right. So hopefully this will give you a little bit of a reminder of what we did here last week. This is the problem we did here last time, was finding out what r was equal to using the same exact data set. So let's take a look at it again. All right, so number 17. The following data represents commute times and scores on a well-being survey. All right, so here are the commute times that we have here. All right, now we're going to look at the questions here just slightly a bit different, okay? So let's look at it here. It says find the least squares regression line, i.e. the line of best fit, treating the commute time as explanatory and index score is the response. Okay, so let's talk about how we can do that here. Let's go ahead. Now we're going to take out our calculator here. We'll come back to this. I'm going to move this over here to the right, and we'll come back and bring the calculator off to the left. I'm gonna make this guy a bit bigger. Yeah, I don't care if you're in beta. Who cares? Let's put this a bit bigger. All right, it's bigger. Okay, just like my ego. Okay, and then we'll do that. And there we go. Excellent. All right. Yes. All right, so okay, so now let's go ahead and enter in both of these in our list. Actually, before we do that, I'm gonna slow my roll here. All right, let's type "got it" in the chat if you have your calculator in front of you. So make sure you have your calculator with you. Type "got it" in the chat if you have your calculator with you. Let's just make sure everybody's on the same page here before we get started. I don't want to be like, oh my goodness, I left you out in the cold, and I would start to feel that. So, all right, very good. All right. Next, okay, Juan's got it perfect, okay. Let's see if anybody else having issues. I think that'll be most everyone. All right. So, now that we have our calculator in front of us, let's go ahead and go through the steps here, our nice little button presses. Let's go ahead and hit the stat key here. We'll go ahead and go to edit, that very first list. Now, if you have lists from before, let's go ahead and clear those out. So let's highlight the list, hit clear and enter. Clear out those lists, clear and enter. There we go. Now let's go ahead and enter in our commute times into list 1. So that'll be our X. So 5 and 15, 5, 35, 50, 7, 5. Okay. And let's look at list number 2 here. List 2, let's put in all our index scores, the scores that we have to the right. Okay. So let's go in and let's see here. All right, let's type in. Please type "pop" in the chat if you have all your numbers entered in. Type "pop" in the chat if you have all your numbers entered into your calculator. make sure everybody's got on board here. I see most people are, but let's make sure everybody's got their, there you go. Thank you, Mako. Hey. All right. All right, pop there. Very good, very good. Okay, now that everybody's got their numbers here in their calculator, let's go ahead and set the second key and the mode key. Just making sure we don't enter anything bad in our calculator. Just make sure we got our numbers set in stone. Okay, next. What we'll need to do after that is we're going to hit the stat key here once again. We're going to go over to calc. All right? So again, I'm going to go back to the well here from what we did here last week. So we're going to stat, calc, and then we're going to go to number 4 here, which says linreg ax plus b. Oops. So this is what we want to do here. Let's go down to number 4, linreg ax plus b. Now, if you have the new school calculator, this is what you'll see. If you have the old school calculator, you'll need to enter this in. You'll have linreg ax plus b on the top here. Okay. And you just need to hit L1, L2. Okay, so remember L1, L2 if you have the old school calculator. You'll need to hit 2nd and 1 for L1, hit the comma key, 2nd and 2 for L2. If you have the new school calculator like what you see here on the screen, the X list should be L1. If there's nothing in there, okay, or then if it's blank, just hit 2nd and 1. It should be defaulted to L1, but just in case. If there's nothing in here, Y for whatever reason, then 2nd and 2 for L2. Leave everything else alone, okay? Make sure that there's nothing entered in for the next 2 spots for frequency and store. You don't care about this. And then go ahead and hit calculate after that. Okay. Alright, so this is what we have here. Alright, so what I would like you to do is type Professor Chib's smells in the chat if you have these exact numbers here on the calculator. So you can type Professor Chib's smells. That's perfectly fine. That'll be okay. Very good. This is not a bad thing. Smelling fresh. Tori's like worried. Very good, very good. Alright, let's see if anybody else is having some issues there. Alright, so good thing everybody has these exact numbers here. Now, let's go ahead and take a look here at our overall results, okay? So that part is important here. So, the 2 numbers that we want to focus on here specifically are these first 2 numbers we see right here. This A will reflect our slope, okay? So notice it says y equals ax plus b. Essentially, this A here will be our slope. So here we have y is equal to negative 0.0479 x. And then we'll add to that the b here, which is our y-intercept of 69. Nicely done, 0.296. Alright, so that's effectively what we have here for our guy. This is our line of best fit right here. Okay. Any questions about that so far? We're going to answer some questions in relation to this, but first and foremost, any questions so far? Let me put this on the left here for right now. Okay, so we need to answer. So what we need to do next, ladies and gentlemen, is we need to answer some important questions that will definitely come up here on the homework and probably will come up on the test here. So let's talk about letter B. Okay, let's talk about letter B. And I will discuss a couple of things here in relation to things in letter B. Now, letter B says interpret the slope and y-intercept. Okay, so how exactly does this work? Okay, all right. So the slope, like we've mentioned here, is the rate of change, but it wants it in terms of the context of this particular problem. Now, this basically says this: x is representative of the commute time in minutes. So the way the rate of change works, it says, all right, basically says for every minute, the index, the well-being index. Hey, Dylan, my friend, how are you? Good to see you. I haven't seen you in a while. Where have you been, my dude? So, for every minute, the well-being index reduces. For every minute, I guess I should say of commute time. Supporting others, man. I respect that. How's school in Liverpool treating you, buddy? I hope you've been doing well. Been tired yourself? Hey, you're all more than welcome to come in here anytime if you need some refreshment. I got no problem with that. So, for every minute of commute time, the well-being index will decrease. Again, this is a decrease here. It will decrease by... That's the rate of change that we have here. Decrease by 0.0479. Had reading last week, back to uni this week. Alright, and was denied entry because I didn't... Oh, that's not nice. You gotta have a student card and everything. Man, you might as well just come to America. They just let you on campus. You just walk in on campus, like, cool, man. Here you don't need any cards. Here you just, like, there's like 5,000 entrances, and you could just walk into any one of them. Ah, yes, that's true. That was that taxi thing at the hospital, right? Yeah, I guess you have to kind of be up on guard about that stuff. So, yeah, that was pretty crazy. People are crazy. I'm just glad nobody was. I'm just glad that the taxi driver, man, that guy's pretty smart. He did the right thing. All right, gotta hand it to him. That was pretty clever to lock the doors on the guy. So, I ain't gonna lie. Man's a total legend, absolutely. Alright. So, letter B here, again, talking about the slope. For every minute of commute time, the well-being index will decrease by 0.0479. That would be, again, just really quick here, would be reflective of your slope that we have right here. Now, if we talk about the y-intercept, I'm going to talk about the y-intercept here. Now, here's the thing about the y-intercept, okay? The y-intercept here is not an appropriate thing to interpret. So, not appropriate. Now, exactly why is that the case here? Why is this not appropriate to interpret? This is because 0 is not a possibility. Again, normally a y-intercept would reflect, say, hey, that would reflect 0 minutes. Problem is that 0 minutes is not part of our data set, okay? If 0 is not part of your data set, then the y-intercept is not going to be appropriate to interpret. Okay, if it is part of your data set, then fine, you can go with it. But 0 is not part of my data set, so it's not realistic. Okay, so therefore, again, I can't do the y-intercept here, at least in this case, for interpretation. Did that happen near you, Dylan? That incident with the taxi happened near you? I mean, obviously it happened in Liverpool, but I don't know how close the hospital is from where you stay. So, all right. I'm waiting an answer from my boy. All right. Any questions about that so far? Any questions so far? Nope. All right, good stuff. All right, let's look at letter C here. I want to talk about letter C. Not remotely close, maybe like a... Okay, that's good. That's good. 15, 20-minute walk away. Okay, that's good. At least it wasn't close to you, man. Happy to see that, my dude. Yeah, for those who don't know, there was a... you probably... If you hadn't read about it, yeah, there was a... where my boy Dylan lives in Liverpool in the UK. Yeah, there was a terror attack using a taxi. Taxi driver was pretty smart, locked the guy in the car with the device that was set off, and then the taxi exploded in front of the hospital. So the only guy that got killed was the actual guy who was trying to detonate the device. And then they arrested a few more people in connection to the crime. So I give the taxi driver a lot of credit for preventing a further tragedy. He was going to the memorial service. Wow. Well, you gotta give that taxi driver a huge pat on the back for being a G, a legit G. All right. Yeah, right. The taxi driver should get paid more. Taxi driver should get like 100,000 pounds for saving a whole bunch of people. Like, dead serious. Yeah, I can imagine. I'm sure that whole place is like on high alert now. What is going on out there, though? People are crazy, man. I know some people are crazy, but geez, my goodness. Look, look, what I'm content is just to watch videos of road rage. Okay, we don't need any of this, right? Alright. Okay, fair enough. Fair enough. Alright, we'll see you a little bit, Dylan. Alright, let's look at letter C, ladies and gentlemen. Alright, so, let's look at letter C. Now, again, in letter C, we can go ahead and make a prediction, okay? We can use our line of best fit as a model in certain circumstances to see what in this case, our well-being index would be with a given amount. So in this case, you predict the well-being index of a person whose commute is 30 minutes. So, here we have a 30 minutes sort of deal. Again, all we're going to do is do the simplest thing possible. We're just going to plug in 30 minutes in for X into our guy here. Simple as that. Okay. So just plug in 30 in for X, and we're going to get our prediction. Now, why is 30 minutes okay? Well, 30 minutes is okay because it's within our commute times. It goes from 5 to 105, so 30 minutes is somewhere in between. So we can make a, somewhat accurate prediction. Let's go ahead and take a look here. Yeah, it's not going to be exact, but, nothing's exact in the world, so... In terms of this, anyways. 296. Okay. So here we get 67.5926. Okay, And there we go. Perfect. Alright, and so that's how we can predict the well-being here. Now, let's take a good look here at D. Alright, and then I'm going to actually extend this out just a little bit further here, guys. So, this one example is very, very helpful because it's going to show pretty much everything that we're going to be doing here in this section. So, let's look at letter D. It says, suppose that Barbara has a 20-minute commute and scores 67.3 on the survey. Is Barbara more well off than the typical individual who has a 20-minute commute? Okay, so this is basically kind of doing a little compare and contrast. So here, let's say y. Let's just do it with the model here. So let's do it with the model first. Let's plug in 20. Okay, and really quick here. Does anybody have an answer for me here? Anybody have an answer for me? Minus 0.0479 times 20 plus 69.0296. Have you guys get involved a little bit. Who's got an answer for me here? $68.0713. All right. Okay. Now, if we look at that, that should be the well-being. That should be the well-being index here. So if we look at Barbara's case, and she has a 20-minute commute and scores 67.3 on the survey, is she well off? Is she better or is she worse? Is Barbara better or worse here, according to this problem? What do you guys think? Is Barbara better or worse according to her results in Part D? Now, this isn't too hard, guys. You just have to compare. So Barbara has a 20-minute commute and scores 67.3. Barbara is my queen. But everybody says better. So is Barbara more well off? Well, she scores a 67.3, but underneath the model, you should score 68.0713. So I would say because this is a well-being index, you know, the higher the well-being index, the better you are. Actually, in this case here, Barbara is worse, actually, guys. Barbara is worse. 67.3 is going to be less than the 68.0713. Yeah, so actually she's not better off. She's actually worse off. I know that kind of everybody's like, I've let you down, Barbara. I'm so sorry. Kill Machine's like, no. What have I done to my queen? Oh my goodness. Oh man. I will defend her with sword and shield. With all your might. I do. I trust you, Kill Machine. I trust you, buddy. I'll just sit back and observe. That's what I'm gonna do. I know your passion. That's why I take a step back. I said I'll let the man of the hour handle this. You know, for Barbara, it's all good. All right. Okay, so that's part D there. Now, the last thing that we're going to talk about here, at least in terms of the new concepts, I'm going to extend this question out just one bit further. Okay, let me go ahead and explain. I want to see exactly how well this estimates, okay? How well it estimates. And to do that, we're going to use existing values within the data set in order to help ourselves out. So let's say, for example, here, I want to see, I say, okay, well, what if your commute time is 25 minutes? How about if we compare what the model says in comparison to what the table says? Okay, now, in order for us to fully grasp this, what we talk about is we talk about what's called the residual of a data item. Okay, we talk about the residual of a data item. So to find out the residual of a data item, this is taking the observed value, that's the one thing in the table, minus the model, which you use the line of best fit. So again, we'll use observed, again, to find this residual, again, is observed minus the model. Now, let's use it in the context here of this problem. Okay, so if we use this in the context of this problem, let's say, for example here, just as an example, let's say x is equal to 25, okay? So if I want to find the residual here, all right, let's find the residual. First of all, I look at the observed value. Now, the observed value here, according to the table here, is 67.5. That's the observed value, because that's, again, what's given to us here in the table. So we would put 67.5 for the observed value. Now, if we want to find the model here specifically, we need to go ahead and figure out what that is using the line of best fit here that we just found from the very first part. So let's find out what is using the model here, and then we'll plug that in up top, and then we'll see what the difference is at the end of the day. So you get minus 0.0479 times 25 plus 69.0296. All right. So does anybody have an answer for me here? What we got here? Negative 0.0479 times 25 plus 69.0296. What's our blank answer here? My answer for the model for x is equal to 25. That's what I'm trying to figure out on the bottom here. Whoa, 57. Oh boy, that's a little bit too small. I don't know what the answer is. I'm gonna keep it. That's okay. Well, I'm looking good today. Thanks, Kill Machine. I appreciate it. The beard is coming in okay, but I might shave it off again. You know, might be a time for another hard reset. The hair comes in really slow. You know, being old. Oh, forgot to put another. Oh, well, yeah, that would help. 67.8321. I was like worried, like, wait, what? All right. Okay. So let's see what the difference is. Let's see what the residual is. Okay. So if we did 67.5 minus 67.8321, what's our answer here going to be? What we get if we take 67.5 minus that 67.8321? What's that difference there? Anybody got an answer for me here? Negative 0.3321. Okay. Alright, good. Okay, so the residual here is negative, and that's perfectly fine. In this case here, the model overestimated. Okay, the model overestimates by 0.3321. Alright, as it is bigger than that of the observed model. Or if we took a look at the residual, okay, the residual would be, again, negative 0.3321. That would be how we would look at it. So from a perspective of just a picture here, this would be like the, let's say 67.5 is somewhere here. Let's say this is 67.5 here. All right, we would have a line of best fit, maybe like right here, and then up here would be like 67.8321. I know that seems a little crazy, but still, I just want you to get the visual, very generic. This would be the residual here, the difference between this actual value and the one that would exist on the line of best fit. And this is a crude picture, but it works. You know, that's essentially how we view residuals. That difference right there. All right. Any questions about that? Any questions? Easy peasy, lemon the squeezy. I like where this is going. Okay, here's another question that could come up. This one's a quick question here. This is on another example for number 19. Now, this talks about head height and head circumference and stuff like that for like children. All right. In any case, let's look at this here. I'm going to look at letter G here, and then in the context of this problem here, would it be reasonable to use the line of best fit to predict the head circumference of a child who is 32 inches tall? So taking a look at the chart here, would it be reasonable to use the line of best fit? Zoom out here for a second. What do you guys think? Would it be reasonable to use the line of best fit here for a child that's 32 inches tall? Yes or no? The 19G. Would it be reasonable to use the line of best fit? That's the question that I have here. Put that down. There we are. Would it be reasonable to use the line of best fit for a child who is 32 inches in number 19? It's a simple yes or no question. Yes or no. Alright, Jake says no. Alright, so if you say no, why not? Why would that be a no? So if that's your answer, no, you gotta tell me why. Alright, if yes, then why? There's no getting around it. I know that answer is just for you trying to avoid an explanation. That's my guess because the values are not that far from different. Okay? Not sure that that... Not sure that's quite right there. So if no, why? If yes, why? I could tell you... I know the answer, of course, but it's just... You need to be looking at one thing in this particular case. There's a reason why I asked this question because it's asked on the homework and it's asked on the test. So... Would it be reasonable? Look at the, so here's my hint. Hint. Look at the x value. Look at the x values, question mark. What is it about the x values? We saw this in the last problem. I kind of described it in the last problem. Look at the x values. What's the highest x value? What's the lowest x value? You know, what is the lowest and highest x value? Anybody tell me, what is the lowest x value? What is the highest x value? 27.75 repeats, but that doesn't matter. I only care about the lowest and highest x values. Tell me what the lowest and highest x value is. What's that gonna be? Keep it simple. What's my lowest x value, guys? Let's roll with that. Lowest x value is 24.5, and the highest is 27.75. That's right. So if the lowest is 24.5 and the highest was 27.75, okay, then what would be, what is 32 in between 24.5 and 27.5? Is 32 in between? The answer is no, okay? 32 is not in between those values here. So, the rule is going to go like this. The answer is no, okay? So, it means basically it works like this. Is if the value in question is not in between the lowest and highest x values, then it is not appropriate to use the line of best fit. Okay? I'm gonna put that in chat there. Actually, we'll also put it in the thing, the handout. That there. Make this 16. Yeah, cool. I don't know why this isn't Helvetica, but whatever. That's not my thing. Alright, there we go. Oh, that didn't really change a thing. Let's try it. Let me just retype it. So if the value in question is not in between the lowest and highest x values, then it is not appropriate to use. Okay. Alright, there we go. Alright, so I just wanted to add that in here, so that way you guys understood what exactly we're doing. Alright? Okay. Any questions about that? So, normally I would do it if it was like 25. So, for example here, the idea is that if the number was 25, I would be like, okay, 25 is between both of those values. I can go ahead and do a line of best fit. I know it's somewhere in between. That's fine. I can figure out what the model would be. But 32 is outside of my model, so that doesn't make any sense whatsoever. And that's basically how we want to answer question G. All right, for that. The others are pretty much exactly the same questions that we've just talked about here so far, using the same exact methodology. All right. And that's pretty much it. All right. Questions about this section. That's all you have to do, folks. I know it's one example, but it pretty much explains everything you have to do. That's it, guys. Unless you want to do another example, I can, but it's really just the same stuff we just talked about here. No difference. You have a data set, you plug it in the calculator, boom, 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 boom. Easy peasy lemon the squeezy. Questions, guys? Any questions? If you're not sure, you guys can always look over this video again. And you just get the button presses down. But it's pretty much the same stuff. No? Alright. Okay. Alright, very good. So, that pretty much takes care of what I want to do today. I know it's not a lot, but you want to know something? It is still important nonetheless. Alright, that's it. That's it, ladies and gentlemen. That's all we're going to be doing here today. I know. I know you guys maybe think that there was more, but there isn't. That's it. That's it. Yeah. That's all I really got to say. Nice. A nice, short day. I hope, hopefully you guys can enjoy a nice short day too. We only have just a couple sections to go, so, yeah, we're in really good shape, in all honesty. Alright. Very good, very good. We will be back here, once again, on Thursday, at the same time and the same place, okay? I promise you, we will be in good shape. Yeah! Okay. Okay. I want to thank you guys. Very much for coming on out here to the stream. Thank you so very much. All of you are absolutely fantastic people. 100,000% fantastic people. All right, you guys, Kill Machine. Thank you very much. Thank you very much, everybody who came into the stream. Dylan, thank you very much. You guys are awesome. I hope everybody has an absolutely wonderful evening. All right, we will see you back in a couple of days. As for me, I will be back here in roughly about an hour. So for the next 102. But all right, but for you guys, I hope you guys have a wonderful night. All right, and we'll see you in just a couple of days. All right, have a good one, everyone. I'm just to let you know, by the way, I may make a big announcement next week, next Tuesday. I may make a big announcement, so let me just leave you off with a cliffhanger. Okay, I may make a big announcement next week. So, I will, I know. I'm debating it in my mind, but that's why I'm going to leave you on this cliffhanger here. Alright? Going to campus? No. Won't be going to campus, but it is class related, I promise you. But let's leave that for next week until we finish up our material. That's the most important part. Okay. Thank you very much, everybody. Take care, everybody. Have yourself a wonderful day, evening. All right? I love you all. Take care of yourselves. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right. We'll see you next time. See you in a couple days. Have a good one, everybody. Take care of yourselves. All right. Bye. Bye, everybody. Bye, Chioma.